Hi guys, this is Vishal is here. So welcome to my YouTube channel. We learn a Java full course. So today we will discuss about the what is queue in the Java, the queue data structure. So firstly, in that last video we will discuss about the stack data structure. So yeah, in the stack, which is actually the two user LIFO, that is the last in and the first out, and then opposite in that is queue. That is the queue data structure actually. Okay, this is in that the FIFO, that is first in first out. So what is the queue actually? The queue is the collection of it means the linear of data structure that is to the or the collection in the Java. Okay, so in that actually it works on the FIFO, that means first in and first out. Okay, so in that there are two elements which is available. The first one is the front and the second one is the rear. So this is actually the collection to use to use and by using this to perform the queue. So what is a front and the rear? So the first actually to work the element removed from the array, and the rear is actually to add element into the array. Okay, so how does it work into the array? So in that there are EQ, DQ and the peak one. So EQ is actually doing the to add the element in that. Okay, suppose actually we consider suppose one array. In that there is a front and there is a rear. Okay, so EQ is actually sorry, EQ is here. So EQ is actually the add to the element, and the DQ is the to remove the element, and the last one is the peak. So peak actually to only the see the element which is actually in there. So yeah, this is actually the function of the peak. Okay, so EQ, DQ and the peak. Okay, add, remove and to see the only the element. Okay, so in that actually queue data structure there are four implementation of there. So, okay, so four types of there how to implement into the array. Okay, so first we will discuss about the array, so queue by using the array. So we consider one array. In that there are five element 1 2 3 4 5. Okay, so in that what to add what to do the array. So this is the front and this is the rear. So when we remove the element from the front, which actually in the array nature and the queue, the remove the element in from front. Okay, so from to the array. So there is a actually empty element is empty block is available. So in that what, so 2 is a shift through the there, 3 shift is to the on the left side, 4 shift, 5 shift, and when to add the element, so add element by using the rear, and to add element the inside the this empty block. Okay, so actually this is the doing the in the array. So shifted by element, when you remove the element from the front, we when we added the element from the rear, and to remove element to shift the one by one and add to the last one in the last block. Okay, so when we suppose front and the rear actually on the same block overlap, so that time the value is actually the minus one. The rear is the minus one and the front is actually the this is also minus one. So front is actually the fixed and the rear actually the dynamic or movable. Okay, so this is actually the first implementation by using the array. But actually the array implementation actually which is not used because of some reasons. There is in that array there is a size is actually fixed. The size is actually fixed. That's why the more impact in that there. And also the big of NR is there. It means when we EQ, the actually it's work on the big of 1. DQ and the peak actually is to work on the big of n. So this is the big of n actually too much required for time to implementation. There is a more whole required time whenever the array is a big. So yeah, there is a time problem and the size is actually fused. So that's why array is most not used. Okay, but other implementation which is actually most used in the applications. So the second one is the circular queue in the array. Okay, circular queue by using the array. So what is the circular queue by using the array? Suppose also we consider the array in that does 1 2 3 4 5 elements. So in that what when is there front, is there the rear. When we remove the element from the front, the front actually shifted to the 2. Okay, the front actually there is a index of the 1. Okay, there is a block is like empty. Okay, so that time when we added the element, so that time the rear which is going to the this element and to add to the element. Okay, so the rear is actually here, and the right side to the front. It's in what, so front is actually shifted to there, and the rear is actually rear element add to the here, and the rear is there. Okay, so again when we 2 was removed, so that time what, 2 was removed, the block is empty, the front is actually shifted to the 3. So the new front is actually from the 3, and when we add an element to go to the on this empty block and to the there. So this is actually to perform the circular. That's why circular cube by using the arrow. That's why you name the circular. Okay, this is actually to doing the circular. In that the big of 1 for added, big of 1 for remove, and big of 1 for also the big. So that this is this implementation actually used from the applications are in the industries. So this is best. Okay, and no time is which is time is very less. So that's why also. So the next implementation is the linked list by using the linked list queue by using the array. So how it's performed? Suppose also we consider suppose a node like that. Okay, so consider a node. Suppose we consider a 1, 2, 3, 4 nodes. Okay, so in that first node 1, 2, 3, 4 elements will be there. So the first node is actually the head, and the last one is a tail. Okay, so in that what, when we remove the suppose when we add the one node, that is 5. So and 1, 2, 3, 4 5, and in that we remove the one element, one node 1 which is removed. So head is actually to shift to the 2. Okay, and this element actually goes to the in the garbage collection, and new node actually to add it to the to the chain of one node, and tail is actually to shift to the new node. Okay, so new head is a 2, and the new tail is a 5. Okay, and the first node is actually go to the in the garbage collection. So this is actually shift in the linked list. Okay, it means okay. I know if you understand or not. Okay, so this is actually perform the so head and tail. When we suppose when we added the one node, so that time when we remove the node, so this remove the go to the garbage collection. This node actually to the to link with the before node. So that's why link list link with the before node, and the tail is a shift. There is the last one is a tail. There is a new node, and the head is actually shift into the second node. That is the new head, that is 2, and the new tail is actually the 5. So this is actually the work with the linked list. Okay. So the next implementation is fourth implementation is actually by using the queue and the linked list. So in that what? So the queue is actually interface. All of you know. So queue interface using and the linked list class using we actually to implement. Okay, so also one there also by using stack we implement the queue. This is actually the duplicate queue actually is there. So how it's work by using a stack? So there is a to stack. So suppose one array 1, 2, 3, 4, and we added the first element. Okay, so this first element added. So in that first S1, that is stack 1 element there. So one element shifted to the S2. Okay, so the next one is added to the 2 is here. So in that what 2 is here. So that time the 1 is shifted to the S1. The what S1 is 1 and 2. Okay, so this S1 1 and 2 go to the shifted to the S2. That is 1, 2, and 3 is here. Okay, and then 3 is here. So again 1, 2 here, and again 3 is actually is there. Okay, so the 4 is here. Okay, so 3 is here S1, and 2 is in the S1, and 1 is S1. So 4, 3, 2, 1. Okay, so yeah, this is there. And when we to use a stack, that is a LIFO. Last class there is a one first in, second, third, and fourth. This is actually from the queue. That is first in, first out by using the two stack. Okay. So yeah, I hope all of you understand what is I'm saying to about the queue data structure. So thank you for watching. Thank you so much.